Welcome all. It's great to be here. I thank the organizers for giving such a wonderful opportunity for us to present our tool set, pen set AI next gen platform. I wouldn't call it as a tool set. Instead, I would call it as a platform. As earlier, a few of our keynote speakers mentioned about having platform as an important. So somehow we call it as a platform instead of tool set. Though we have multiple sets of tool set in our integration into our pen test, but we still call it as platform. So I, Ajay, as mentioned, lead engineering services at Transfer. We are a San Diego-based company. We still have to create an office in India, but still a lot of engineering work is being done remotely with our team across India. So what I'm going to quickly tell about is about pen test. I know it is going to be a little technical, but I would, with security being an important aspect for all of us today, I just want to touch base about what we do as a platform and how we are enabling community, individual organizations, as well as Transfer's research teams, AI security tools, and how we have integrated a few of capabilities of AI. As mentioned by our earlier speakers, we have been using AI as an ally or a companion, not as a complete dependent system. So what do we do in AI with our tool sets? So with our tool set, with our platform, with pen testing being an important aspect for all our organizations, what we do is we codify, capture the knowledge, expertise of the people who as a team have built over years, and it is codified and put as a manifest so that your offensive tools can be run at speed, so that at speed, at volumes, and consistent. Why that is required? Because a manual testing, though we don't undermine the importance of manual testing, because manual testing again is what one of our previous speakers spoke about, the importance of human aspect coming into picture. But still, some of these tools, integrations, the open source additions, all of them have been collated and put them into our manifest, and then they can be run with volumes of applications, thus reducing a lot of manual repetitive tasks, which helps us to do a precise, frequent testing, and which will give you at any given time a precise snapshot update of your security context, how your system, because as we see, most of our engineering development is only associated with the product features, whereas security comes at the time of when you are going live to your deployments. Whereas we as Transfer try to bring in what is called as development, bring the security as an important part into our development life cycle, which is what we all are here as a part of agile system, where we want to say it has to be all the time up, and all the parts of your product has to be taken care, not at the end of the system when you want to go live for your product. So how have we added the security into our system? So let me touch base here. So some of it, I know some of it is very, very technical. Some of you who, what I want to tell you is these are all the static parts here. The static parts are all where we all know that we write code. We all know we have tools. We have capabilities. We use libraries from different systems. We use secrets for our deployments. All of them add to what you call as your vulnerabilities. So in this case, where we are using AI here in the static part is when we integrate with your repositories on the left side of your system, they add into what is called as, they generate attack emulations. Here transfers a research team on to your right of the central portion where they build your attacks based on certain standard frameworks. The organizations which build their own custom attacks can add further to it. Then there can be community-driven attack systems. Further, altogether can target the applications and then generate what is called a list of application findings which can tell you how vulnerable is your application or your domain so that you are aware as an organization before putting it out in the wild, so that the external hackers or attackers, ethical hackers will let you know that these are your vulnerabilities. Instead, what we are trying to do is bring the whole system of this into your development cycle so that it can add to it becomes a day in, day out process of not only the feature development, in fact, security as a requirement for your system. We also support in our platform what you call remediation. We use AI integration here as well. So we have certain demonstrations that we can show up here where not for these technical requirements, remediation is about how to fix a problem. I know Google, if all of us go to Google, we get a lot of information. But this precise for the resource, for a specific situation, what exactly has to be fixed is what we have done it for our integration. Further, we have risk reports and a dashboard for different roles of your system, organizations where they can be used. Okay, so this is what is our broadly the 3 parts of our system. Okay, so who are we? As mentioned, we are a San Diego-based startup, SOC 2 compliant. Gartner put us at a leading vendor security operations in 2023. We are also integrated with Microsoft Sentinel, SIAM tools, where people who are already accustomed or using Azure platforms can integrate with our system, where all the application findings, vulnerabilities can be pushed into the SIAM tools, and they can continue to use the standard Azure workspace. Some of the awards that we have got in our journey. Yeah, so this is very interesting for us because here we have some integrations in AI here for both a code runtime, for both at the infrastructure level as well as the application that we run in our systems. So what we do is here, when we say code infrastructure, most of the infrastructure that is deployed in our cloud today is basically through infrastructure as code templates. So that is where we also have policy tests, standard industry policy tests that can run on your infrastructure code, and then also can check as soon as they get deployed, they can be checked across on the platform itself, on any of the clouds that we support. Basically, we support Azure, AWS, GCP, Kubernetes, some of these platforms we support. At the application level security, what we do is we have the ability to integrate your repositories into standard code analysis, secret managers, secret testers, then composition analysis. So one of our standard, most of the vulnerabilities that the applications today are hit are mostly by the different libraries that people integrate with the system. So what happens is For that case, we want to bring out an example here about, I don't know if of the most vulnerable recent vulnerability was Log4j. I don't know if in the last couple of years we have had a big set of applications being brought down with very, very high, it was an the highest rated critical vulnerability. So that is why we have what is called as a 0-day as a service. What we do is, at Transfer, our team works in the back end to build these standard test scenarios and then enable them automatically into the people who have, into the customer accounts who have subscribed to the SaaS platform. So what happens is, take the case now Log4j. It was a simple log scenario. What happens, it was a lookup that was being done, lookup log written was causing some malicious code to be brought on from any other server and then executed into your system. That is how the systems were compromised. So what our team did was, now there may be n number of people who are not aware whether they are actually being impacted by this Log4j vulnerability or not. So for them, automatically as soon as they schedule a run, they don't have to do manual testing here. As soon as a automated test starts, it checks if your system, we put a request packet onto your system and then say, can I get back the lookup? If I get the lookup, I know that, okay, your system is vulnerable. But still, before that, I can go and check your code repository. If I can find out through my software composition analysis tool set, if any of these versions affected, it immediately flags as a finding for you. So this is where we are saying we work on a modular approach of code as well as runtime. As soon as the application from a CI/CD pipeline gets deployed, we can run your the standard set of services, which include 0-day as a service as well. Okay, so how do we do our security analysis? That's an important part of our development or deployment. So we have categorized into 5 parts for our system. One is auto discovery, where you give us the assets basically in terms of repositories, domains, your on-prem applications. So we discover them and then create manifest files. Then add the emulation attacks into that manifests and then run the app findings or infrastructure findings. Then we also we can find your risk correlations between your infrastructure and your application. So that is where adds just not like, for example, most of the people do these tests independently. Some of them do only the infrastructure, saying, okay, this is good enough. Then some people do only application testing and then say this is good enough. But nobody knows that because I have kept a hole in my storage, how can it get affected into my application? So that is where we correlate. So if we find any of these findings in one of these areas, we try to correlate with the application and then try to give a result saying that do we have any attacks that can be vulnerable through any of the previous findings. That is why in our previous in the previous one, static scanners, what we say is some of these analyses are fed into the system through AI. So whatever findings have been found here, they are made sure that those additional tests are done during the dynamic testing. So that any of this, even though they may not be vulnerable there, but we keep adding them as a tags, and then the tags load the test automatically and then test the target to make sure that we are not, the end target application is not vulnerable. Yeah, so coming back here, so what happens is So there's a, oh, whatever, sorry. Yeah. So here about the last part of it is about the reports and the dashboard. So as mentioned, our platform allows capability to have any reports, basically configurable reports for any of the roles, basically CISO, specifically for developers, or for that matter, auditors. Those are all compliant reports that we generate out of the platform. Plus, we have ability to have remediations, shift left operations, CI/CD integrations, where we don't have any agents that are installed on our platform. Okay. Okay, yes. So what we do is we go through, I'll take, my son will take you through what we have done for the CVSS scoring for CVSS scoring, where we have used AI very extensively so that it gives us consistent view of our vulnerabilities. What happens is different tool sets give us different levels of security, some of them low, medium, high. So what we have done is at Transfer, to give a consistent view of the vulnerability of the vulnerabilities, we have used what is called as common vulnerability scoring system, which is common across domains. That is what has been done by our what you call CVSS scoring. Initially, we had integrated the AI, but then we have improved over a period of time using further tuning of the model and then achieving better results about it. He will take you through some of these exercises as an AI experimentation that we have done it for our platform. So that is what, these are our contact points. You can touch bases for us. We provide what is called as free tier access to organizations, individuals, so that they can try our platform for 15-day, 3 weeks, 5 weeks period, so that transfer can be useful, integrated into a development platform. So let me hand it over to to Gautam so that he can take it further for the CVSS scoring. Okay, you have it here. I'll take questions at the end of the session after this one.
Hi everyone. I am Gautam. And before I start my bit of the presentation, I would like to thank the organizers for giving us this opportunity to present here, and also thank you to all of you for joining us here. I'm quite excited. It's my first time. So please bear with me, and it'll be slightly technical, but I'll try and make it quite audience friendly. Okay, so I'm working in harnessing the power of AI to enable CVSS scoring. Okay, so this AI integration will actually enable us to develop software faster rather than worrying about vulnerabilities. This system will actually fasten things up. Earlier, traditional CVSS scoring required a domain-specific expert who knew the system. He would take at least a couple of days, okay, to come up with results. And this is at the expense of quite a bit of cost. But now, in this day and age, that system is long gone. Here, what we have done at Transfer is we've integrated AI to score, to give us CVSS results. This offers multi-domain expertise, first of all. So this is doing the job of, let's say, 5 different domains in one place, okay? And then it's doing that at the fraction of a cost, and these responses are instantaneous, most importantly, correct? That's what we require here. And lastly, the thing about this is it still maintains the same consistency and accuracy. All through the morning, we've been talking about a high-level idea of how we can integrate into our business. Let me take you to a ground level of how AI is actually integrated into most enterprises. Okay, this is a general pathway that enterprises might follow when they're integrating AI into their systems. So we start off with basic API calling. We saw a couple of demonstrations earlier where we typed a question into ChatGPT and it gave an answer. That's what it is. It's fairly easy. You can use the paid tier, free tier, that's all right. The next part is prompt engineering. It's prompt engineering, the requirement of prompt engineers is on the rise. So hyperparameter tuning is slightly technical, but fairly easy to do. Next part, the third phase, fine tuning. That's where things actually start getting interesting. That's where you really need a bit of domain knowledge. That's where AI engineers come into the picture. And the last part is retrieval augmented generation. That's the buzzword, actually, in core AI. That's making really big waves around now. Beyond this, once we have a reliable product that's consistent and accurate, we can try and make it more efficient. Okay? So let me take you through the how we've been navigating through the process of integrating AI into our system. We too started off by basic API calling, correct? But it turns out the model was not very consistent. So we would give the same query, but it would respond with different CVSS scores. Let me briefly explain to you why this happens. So LLM models are nothing but very basic stochastic prediction machines. They are only responsible for providing an output. They're not bothered with providing a consistent or an accurate result. They will only give you an output. It's up to us how we leverage this to get the correct response. So in a bid to get more consistent CVSS scores, we moved on to step 2, which is a tri-pronged step, which includes prompt engineering, hyperparameters, and system messages. Prompt engineering is quite a vast field by itself. We have, I've listed a few. There's chain of thought prompting, few shot learning, persona adoption. Earlier we were talking about the Turing test, correct? So it's about differentiating how AI is starting to mimic human behavior. You know, AI is even starting to mimic human behavior in terms of greed. There's a prompt engineering method that if you say that you're going to tip the model, it'll actually respond better. So if you send within your prompt saying, I'll give you 100 rupees for each good answer, it'll actually respond better. Next is hyperparameters. There are two primary hyperparameters, temperature and top P, that are concerned with the consistency of scores. Higher value results in a more creative, in a more imaginative result. Lower values just ensure that you get more deterministic and consistent results. The third being system messages. They are basic guidelines that the LLM must follow in order to respond to the human messages. So what did we achieve through this? We did get quite a good degree of consistency, okay? But who's to say these responses are correct? At the end of the day, the LLM model is still only guessing, correct? So in order to get better, because at Transfer we don't stop at anything short of perfection. We got to fine-tuning. What's fine-tuning? Fine-tuning is an extremely powerful tool that helps you build enterprise, that helps you build models that are specific to your very enterprise. Fine-tuning. So fine-tuning, what are the benefits you may ask, correct? There is domain-specific expertise and which eventually translates into a faster inference, which is going to benefit your end users. What else? There's tone and format of response. You're going to get a fixed tone and format based on what you train it on. In addition to this, it saves you on further recurring costs in terms of the reduced number of input tokens. What else? We already had consistent results from the previous step, correct? Now we can afford the luxury of even accurate steps. But let me just give you a heads up. There are always two sides to a coin. Fine-tuning comes at the additional cost of the obvious. Monetary expense, and there's a requirement of high quality data. We spoke about how much data is being produced each day, but it's still very important. I cannot emphasize enough how crucial it is to have well-curated and high-quality data to get the results that we desire. So at Pransa, we have integrated a GPT-4o mini model trained on over 7,500 data points obtained from the official NVD database. So what have we achieved with this? We've achieved 80% accuracy of CVSS scores along with consistency. So we've really jumped up quite a few notches from where we started off, correct? But some of you may ask, what about the remaining 20%, right? We still got to do something about that. So it turns out the model finds it difficult to predict vulnerabilities that have a low severity. It's natural because we spoke, I think Mr. Iyer in the morning spoke about cases that are unpredictable, that are very rare in nature. So low scores are quite rare, okay? So that's why the model finds it difficult. So what do we do? What's the next step, right? There has to be a solution to this. So like I mentioned earlier, it's RAG. RAG is short for Retrieval Augmented Generation. Retrieval Augmented Generation may be termed as the torchbearer of AI, if I may say, okay? So it's Retrieval Augmented Generation offers many benefits too. It's very useful for data that evolves over time. Again, and if you're a customer-facing enterprise, let's say, you can have your guidelines, you can have your rules, you can have your other documents, and these documents can be provided to the LLM at runtime that will help it make a better and more informed decision. You see a diagram there. I'll try and briefly explain it to you in as few words as possible. So we have our data here. So it can be structured, unstructured, and that's converted into embeddings. Embeddings are nothing but numerical representations of text. Those embeddings are stored in a vector database in the center, and then here's the user. We send in a query. It's converted into embeddings, a numerical format, and that's queried against the vector database. So data that is most similar to what we've asked is retrieved and passed on to the LLM. So thus the name, retrieval. We retrieved relevant information, and we're augmenting the generation response from the LLM by supplying the retrieved information. So this is work under progress here. We are just short of implementing a Redis vector store populated with over 95,000 records from the NVD database. It's implemented using Llama Index, a very robust platform to build production-ready systems, RAG systems. Yes, so these were the 4 basic steps, and beyond this, there's still greater scope for more improvement. We can cut costs by using open source models. They're free to use. We can improve the data quality and data quantity by adding more metadata. We can increase the data set, improve efficiency. That's crucial to any business, right? We got to evolve. We got to find new ways to make our product better, right? Then we can set benchmarks, which will serve as a testament to the quality of our product, right? So does anybody have any questions for either of us, or I can move to the results appendix?
Thank you for your beautiful presentation. So I understand that you use the RAG. So I have only one question. I saw the record number is very high, which you are going to store into the vector database, right? So is this the system already in work? Means I want to know the latency because you are going to do the semantic search, right?
Yeah.
So what is the response time you are getting? Are you satisfied with that?
In our staging environment, we have implemented it, and from what we have, it's not a production-ready system because it's in staging, and it is around between 2 to 3 seconds. We're still trying to improve it. Does that answer your question?
Yes, yes. Thank you. And there was on slide your father was presenting.
Yeah.
The metri source you are feeding to the AI, right? MITRE.
Yeah, MITRE IDs, yes,
MITRE,
yes,
yeah.
yes.
So I have a little knowledge on that.
Yeah,
I
please.
just want to know that what you are doing to that,
Yeah, so what we do
how
is...
you are using that.
Okay,
Thank you.
so let me answer that quickly, now that we have time. What we do is, to answer that question specifically, see, MITRE IDs are common framework of MITRE IDs kept by the open source organizations. So what happens is, whenever there is static analysis that we do, so we feed them into our dynamic analysis. Based on those MITRE IDs, CV IDs, we keep them and then run only those specific dynamic tests. Correct, we keep it from using the AI. That is where one of the AI integrations is also in that. So what, as mentioned by most of the speakers here, we are using AI as an augmenter. Correct? Not that the crucial or the crux part of our system is run security analysis of the system at the static, infrastructure and dynamic. Correct? So before we actually go to the dynamic systems, we first do a static analysis. Then feed those findings into our AI system. Query them and then say, okay, these are the vulnerabilities. Then we say, okay, do we have any associated to these vulnerabilities, do we have any tests into our, from our custom attacks? Then we add them into our dynamic tests. Correct? You understanding? It's a pipeline of system. Correct. Yes, absolutely. Yeah. Yeah, we are doing it runtime. Yeah. So that is what it is, always updated all the time. So that is what I emphasized about 0-day service, where you as a customer, you have signed with us, correct? So you don't have to worry about the latest vulnerability that is in the market. So Prancer research team will build on that and then identify if your system is vulnerable to that. That is how we are proposing, or we have implemented that 0-day service. Yeah.
Any other?
What? No, not specifically. I didn't get in what context you are talking about.
There are a lot of vulnerabilities, right?
Yes.
So I just wanted to know what are all the vulnerabilities and how can you mitigate it?
See, we work on OWASP top 10. So like for example, you have if you go back 4 years back, the top was your SQL injections, correct? Now what happens is, now as people have all plugged the SQL injections, because the data layer has moved back into a microservice separate layer, correct? Most of your organizations move the data layer out of your exposed attack surface, correct? So then what happens is, now what is the most top vulnerabilities are your identities, correct? Or now with zero trust networks, like for what we say is, nowadays it is not anymore I am in a DMZ zone or internal network, external network, nothing like that. As soon as I am allowed to come inside this, so I can move around the whole aloft everywhere, correct? Similarly, as soon as you allow a request to come into your network, it is as good as it can go around anywhere, correct? So that is what we also check about, like OWASP top 10 is about identity, authorization, and these standard checks like man in the middle, CSRF, these checks are being done automatically. That's what we do.
Thank you.
Yeah.
Anyone else? Did ma'am have a question?
Static analysis which you are doing, so what kind of tools?
Rules. Okay. So we have currently integrated with SameGrep, okay, and we have our own rules, and we support a lot of policies, right? All the popular language sets we do support. Plus composition analysis, the standard ones is the Google standard database set, which is which has records for all compositions, right from Java, your lean stack, your Go frameworks, all of them, you name it. So it can really tell you, I don't know if I could have shown you, also I can show you on an, where exactly it will tell you, point to what version of it is affected by what CVID. And then we also suggest what exact version you have to use it. Correct? So that is how we feed it into your, from the static analysis into the dynamic analysis. And then we go and check that specific CVID as well.
One scenario is when we do this, usually the pen testing, which happens on multiple products or multiple applications, we have either we'll have the same kind of vulnerabilities or maybe slightly different. So are you feeding those vulnerabilities into your system?
No, we don't. So what we do is, see, I understand, like an organization may have 5 applications, correct? So more or less an organization's pattern of code development patterns are more or less the similar. So if there is a vulnerability about identity management, or it could be authorization, so most not all 5, maybe 3 may have the similar vulnerability. We don't feed from your data into back to our systems.
Okay.
Because most of the people don't want that data to be fed back into our systems.
Okay. Because
So what we do,
my this one was, so if for example, if in a particular organization, if you're using, so the common vulnerabilities which are there in one product or one app, maybe that those can be, if those are fed into the system, those could be actually.
Yeah, maybe a good idea, I agree with you, but then we have to take a NDA signature from people saying that we are using your data.
Yeah.
So which we don't do that. Yeah.
Brand new, if you see brand new threat that you never analyzed, how do you tackle that case, sir?
Yeah, yeah, it is as good. I know we may not be the best security experts, but we have people on our panel, we have consultants. Like for example, you take CV database, it is so wide, huge, and the variations are right from your hardware to your libraries, specific applications, they're quite a huge number. I may, like for example, Prancer may not know it, but then we go and I aggressively try to figure it out and then bring a, as an example I told you about log4j, correct? So it was just an example of a lookup, an LDAP lookup. LDAP lookup was causing a complete remote execution on your systems. So similarly, if there is anything new that comes up, assume that tomorrow we have a vulnerability that is exposing a specific virtual net problem. So which if we are aware, we try to solve within our research team. Otherwise, we go to the associated specific cloud providers. If it is only on a specific, then we try to build that custom attack into our system.
Thank you, sir.
Yeah.
Okay, I'll just quickly run through the results appendix. Give me 2 minutes. So this is a sample system message where we have told the AI model to adopt a cybersecurity persona. We have given an example within the prompt that's called few-shot learning, and then we have clearly iterated reinforced what we expect the model to do. Yeah, so this is what prompt engineering basically looks like, and at the end, these are the results that we've obtained. So these are CWIDs. I haven't returned the whole description of the vulnerability, and this is the actual NVD assigned score. And these are the results from the models. So you see how we've progressed from red, a little bit red and green, and to a lot of green, right? So this is what we've achieved so far, and we're looking to move more, get a completely green table with RAG. And there's a fun fact. It turns out that LLMs can't really do math by themselves, okay? Because it might come as a surprise, but it turns, like I mentioned, they're just the prediction machines. They only predict stuff. They've seen 1 + 1 = 2 so many times that they just know it. They don't really know what it means. So how we figured that out was actually that, so we would tell it to predict CVSS scores. Okay, so it's a number, it's a decimal number. So it would give us a vector string in the answer, but it would, in the multiple attempts, it would give us 4.6 and 3.8 and different scores. So it just knows that a vector string that looks like this should get a score in this range. So it guesses. So a heads up if you're ever trying it out, it's good with text, not so good with numbers.